Laws of light refraction. 1. When a light ray travels from a less optically dense medium as air to a more optically dense medium as glass, it refracts towards the normal at the point of incidence on the separating surface between the two media. Two. When a light ray travels from a more optically dense medium such as glass to less optically dense medium as air, it refracts away from the normal at the point of incidence on the separating surface between the two media. Note: when a light ray is incident, perpendicular to the separating surface between the two transparent media of different optical densities, no refraction occurs. The absolute refractive index. It is the ratio between the speed of light in air and the speed of light in another transparent medium. The absolute refractive index of any transparent medium is always greater than 1 because the speed of light in air is always greater than that in any other transparent medium. Critical angle and total internal reflection. Activity. 1. Fix a source of light near the base of a trough filled with water at one of its sides to be able to control the angle of incidence of the ray. 2. Start to increase the angle of incidence gradually and notice the angle of refraction of the light. Observation. When the angle of incidence increases gradually, the angle of refraction increases too. And at a certain angle of incidence, the light ray refracts tangent to the separating surface, and such angle is known as the critical angle. When the angle of incidence increases more than the critical angle, the light ray reflects instead of being refracted. Conclusion. 1. When the angle of refraction in the less optically dense medium, as air, is 90 degrees, the angle of incidence in the more optically dense medium, as water, is called the critical angle of this medium. 2. When the light ray is incident in the more optically dense medium with an angle greater than the critical angle of that medium, it reflects in the same medium, which is known as total internal reflection.